discrete probability distributions. For any random variable, there is a corresponding probability distribution which describes the probability that the variable will take a particular value. So all that means is, for everything you're looking for, there's a probability distribution that lets you know what's the odds of getting every single thing. Now, the key thing to keep in mind here, if you add up all the probabilities, it should only equal to 1, or the lowest you can get to 0. You can't get a negative probability, right? So, and the probability of any one thing is between 0 and 1. When you add up all the probabilities, it should equal 1. The max probability is 1, so there we go. And then when you write this, that describes the probability distribution of x. So this lets you know what's the odds of everything happening. Now, the key thing is that when we're talking about x, we're talking about one outcome. So like, let's look at this example. For example, suppose x is the number of heads obtained when 2 coins are tossed. So that's the key part. I'm not going to look at the rest of it. Let's look at that part. Suppose x is the number of heads obtained when 2 coins are tossed. What happens when you toss 2 coins? Right? You get a heads, you can get tails. Right? We're going to toss it. So if we toss a coin, one option is you get heads and tails, or you get tails and heads, or you can get heads and heads, and you get tails and tails. If all we're talking about, x is the number of heads you obtain. That's all x is, the number of heads you obtain. So that means this first one here, I got 1. Let me erase that. Because again, x is the number of heads you attained. So x is 1 here, you got 1 head. On the next one, x is also 1. You're going to get heads once. On the next one, x is 2, head. And the last one, x is 0. Right? So again, the question is, how many heads did you attain? And your answer could be one of 3 things. I got no heads, I got all tails. I got 1 head. You either got head tails or tails heads, or you got 2 heads. So that's why x could either be 0, 1, or 2. And then the probability of that is, well, look, how many times did I get 0? 0 happened 1 out of 4 times, right? These are our 4 options. 0 happened 1 time. So 1 out of 4 for 0. 1 head happened twice up here, these two, so 2 out of 4. Or 1/2 if you reduce it. And then when you got 2 heads, that only happened 1 time, heads, so that's 1 out of 4. So that's how probability distribution works. X is like the amount this one thing is going to happen, is like what are the odds of that one thing happening, and then what's the odds of that happening, basically. Now that we know this, right, so this is saying 0 heads, 1 head, and 2 heads, and we have the probability distribution. There's lots of ways you can show it. One way is you can do a bar graph. So here's 0, that happens 1/4 of the time, 1 happens 1/2 of the time, and 2 happens 1/4 of the time. Or you could do what's called a spike graph. Either way is fine. Uniform discrete random variable. So this just means all the odds of getting any single one of them are all the same. So when that happens, we call that a uniform discrete random variable. If you look at here, the odds were not all the same, right? 0, 1, 2. But something like rolling a die, in general, gets you like odds of getting any single one thing is 1 out of 6, right? So everything's 1 out of 6, 1 out of 6. That's called a uniform discrete random variable. Mode and median. Mode's the most often digit, I always say. So mode, I always think about it as most often digit. If you want the E, ever. And median's the middle one. So like I always write the median lowercase because right there, see how like there's that D? That lets me know it's the middle one. Because there's a little line right there. So that's all that means. I don't know why I did that. Mode is this one that happens the most often. Probability. So over here, my mode would be 1. That happens the most often. And you can see from here, most often. And then the median is the middle one. So it's the halfway mark version of it. So over here, it would also be 1 because if I have 4 options, 1's in the middle. Or I have 3 options, 1's in the middle. That's mode and median. So let's do an example. The magazine store records the number of magazines purchased by its customers in 1 week. 20% purchase 1 magazine, 38% purchase 2, 21% purchase 3, and 13% purchase 4. And only 5% purchase 5. Let X be the number of magazines sold to a randomly selected customer. Say the possible values of X. Well, again, we're talking about the number of people that sold magazines, right? So you could buy, based on this, you could buy 1. We're not counting people that didn't buy magazines. Only people that bought magazines. So you could buy 1 magazine. So X could be 1. You could buy 2 magazines, 3, 4, and 5 magazines. So it could be 1, 2, 3, 4, 5. So the only values for x I could have, right? Because x is the number of people that bought magazines. So you have to buy at least one, and then you can buy more if you wanted to be in either group. Construct a probability table for x. Okay, let's do that. So here's my x, here's my p, that's how it goes. X would be 1, 2, 3, 4, 5. Something like that. And the probability of each one, we're just going to write it down. They tell us. Week 1 is 20.23. Week 2, buying 2 magazines is 0.38. Buying 3 is 0.21. Buying 4 is 13, so 0.13. And then either watch out for the last one. It's 5%, not 50%, 5%, so 0.05. Yeah. So that's my probability table right there. Graph the probability distribution. So now I'm going to graph it. So here's x, here's p. 1, 2, 3, 4, 5. Now generally p, the max probability is going to be 1, so it'll be your top. So over here it'll be like 0.5-ish, 0.4, 0.3, 0.2, 0.1, 0.6, 0.7, 0.8, 0.9. So again, max probability is generally going to be 1. I mean, always going to have the max be 1. And anything else you want to write. So then we have this. First one's 1 and 0.23. I'm going to do a spike one because it's my favorite. Oh. 0.23 is around there. Like that. 2 is 0.38. So around 4, close to 4. 3 is 0.21, so a little bit past 2. 4 is 0.13, so a little bit past 1. And then 5 is 0.05, so like less than 1 here, so like that. And you can see right there, based on this, 2 is the most often one. So they want me to find the mode. Mode's the most often, so mode will be 2. The median is the halfway mark. So you gotta think about this. If you have 100%, halfway to find the median, the middle, right, would be 50%. So we gotta find where does 50% land. So if you add up these two, so like at the end of 1 you're at 20, you're at 0.23. So like the total. At the end of 2 you're at, add those two up, you get 61. And then if you keep on going further, I'm gonna be at 82. I'm gonna be at 0.95 and then 100. Like kind of if you end up adding up all these. So at 0.23, at the end of 1 I'm at 0.23. At the end of 2 I'm at 0.61. And you keep on going. But remember, we're trying to find the median. The median is halfway, so 50. Where does 50 fall? Between these at 2 somewhere. Somewhere in 2 I get 50%. Like I went from 23% to 61%. So 50 must have ended up in the 2s. So my answer to both of these is 2. Okay, next one. We can also describe the probability distribution of a discrete random variable using probability mass function, which is this. So that's when they give you a formula to find out the probability distribution. That's all that means. The domain of the probability mass function is set to be the possible values of the variable. The range is set to be the outcomes. Okay, so they want me to show that this is a valid probability mass function. So what does valid mean? That means when I do all the probabilities, it should equal to 1. Right? All probabilities we add up should equal 1. So if this is a valid one, when I do the probability, it should equal 1. So what's going on here? You could make a probability distribution if we want. It makes it a little easier. So here's x, here's p. Try out 1, 2, 3, 4. Now, how do I find the probability? Well, they give you the formula for it. Don't sweat it, just plug it in. 1 squared plus 1 is 2, 2 over 34. I'm going to leave it 2 over 34 for now. You'll see why in a second. I found the probability of 2 is substituted in. 2 squared plus 1 is 5, so I get 5 over 34. Substitute in 3. 3 squared plus 1 is 9, plus 1 is 10 over 34. And substitute in 4. Plug in 4, I get 16 plus 1 is 17 over 34. So those are my probabilities of this thing here. Now I want to know if it's a valid probability. So if it's a valid one, when I have the probabilities, it equals 1. That's why I didn't reduce it, because I knew they were all going to have the same denominator. So is it valid? Let's find the sum of the probabilities. So 2 over 34 plus 5 over 34 plus 10 over 34 plus 17 over 34. So this is 7 plus 10 is 17 also. So it's like 17 plus 17 over 34, which is 34 over 34. So 1. So it does hold up, right? It's valid when the probability should equal 1, and it does. If I add all these up, it equals 1. So it's a valid probability mass. Let's do this next one here, or the last one. A policeman inspected the safety of tires on cars passing through the checkpoint. The number of tires X, by the way, that's a British spelling of tires. That's what that is. Which need replacement on the car, followed by the probability distribution below. So X is the number of tires that need replacement on the car. So a car maxed out generally at 4 tires. That's why I hate when that happens. That's why you see 4 is max here. These are people that need no tires replaced, 1 tire replaced, 2 tires replaced, or all 4 replaced. So the first question here is find the value of K. So how do I do that? Well, what did we talk about? If you add up all the probabilities, it should equal 1. So that's how I'm going to find K. So I'm going to go 0.68 plus 0.2 plus 0.06 plus K plus 0.02 should equal 1. Because anytime you add up all the probabilities of the distribution, it should equal 1. So let's add this. This is 88 plus 0.06 plus, so 96. 0.96 plus K equals 1. Just do some math. And I get K equals 0.04. Or about 4%. So there's my K. Find the mode of the distribution. Well, now that I know K is 0.04, right, the mode would be the most often, which is 0. By the way, if I wanted the median, remember median's halfway. Halfway is 50%. Well, that happens at 0 also. 0 goes from 0. 0 goes from 0 to 0.68. So 0.5 is in that. And then this one, find the probability that X is greater than 1 and interpret its value. So let's do that. So for C, I want to find the probability that X is greater than 1. So here's 0 and 1. Again, notice it's X, right? So X is the top here. I want greater than 1. So I only want these values here. So that's 0.06 plus 0.04 plus 0.02. If I add all that up, I get 0.12. So about 12%. So interpret this value. So there's a 12% chance you need more than 1 tire replaced. Or you could say 2 or more. It depends how you want to write it. So there is a 12% chance you need, you could say at least 2 tires or more than 1 tire replaced. Sorry. So that's what that means. So there's a 12% chance that you're going to need more than 1 tire replaced, right? X is the number of tires you need to replace. 0 and 1, 2, 3, 4. Since greater than 1, that just means 2, 3, 4. Okay, so the real last one here. Find K such that following probability mass. So they want me to find K if this is a probability mass. So all we're going to do here is substitute these guys in. That's all we do here. So I'm going to plug these guys in for X. So I'm going to get, when I plug in 1, I get K1 plus 2. When I plug in K equals 2, I'm going to get, oh sorry, X equals 2, not K. I get K times 2 plus 2. And then when I substitute in X equals 3, we get K times 3 plus 2. So I'm going to get 3K here. That's a 3. I'm going to get 4K here. And then here I'm going to get 5K. So it wants to know, how do I figure out what K is? Well, if it's the probability distribution, when I add them up, they should equal 1. It's a probability distribution. So you add these up, you get 7K plus 5 is 12K equals 1 divided by 12. And I get K equals 1 over 12. So there we go. That's the answer, and that's the notes.